We are taking the first chapter, that is the rational number. So we have frequently come across certain equations like this: x plus 2 is equal to 13. Now this kind of equation, what is the solution of this equation? There are certain way, means you have to put something in this x so that when it adds to 2 it becomes 13. So when we solve it, if we can just solve it, we can subtract 2 from both the sides, that is minus 2 here. Then 2 gets cancelled and 13 minus 2 is 11. So it gives you 11. So x is equal to 11, which is actually satisfying this equation. So this 11 is actually the natural number. Natural numbers are the natural counting numbers, and these are called natural numbers. But if we take an equation like this, x plus 5 is equal to 5. Now we again want to solve some value or x for some value, so that when we add this to 5 it becomes 5. So the possibility is, if we subtract both sides by 5, we get what? We get 0. This gets cancelled out. 5 minus 5 is 0. So you get a whole number, 0. What is this whole number? Natural number, that is the counting numbers 1, 2, 3, along with the possibility of 0. These are the whole numbers, right? Now let us take one more equation like this: x plus 18, which is equal to 5. Now in order to solve this, if we subtract both sides by 18, we get 0 here, but on this side we get minus 13. So what is this number? This minus 13 is not a whole number. So this comes under the category of integers, which is positive and negative, which can be negative and positive. So if I can show you it on the number line like this, these are 1, 2, and so on and so forth. Similarly, on the left hand side we have minus 1, minus 2, and so on and so forth, right? So these positive numbers are actually corresponding to the natural numbers only. So all these equations like this, 2x is equal to 3, 5x plus 7, now falls under certain different categories. For example, if I want to solve this 2x is equal to 3, let me divide both sides by 2. It gives you x is equal to 3 by 2. So this 3 by 2 is neither a natural number, nor you can say it's not an integer. So it doesn't fall in these categories which we discussed. So this is actually a rational number. Rational number means any number of p by q form, a numerator and a denominator. So this comes under the category of rational numbers. Properties of rational numbers. Closure property. This property says that when we add two numbers, means if we add two whole numbers are natural numbers inclusive of 0. So if we add two whole numbers, you'll get a whole number. If you subtract two whole number, you are going to get the number which is not a whole number. So when we talk about the closure property in terms of whole numbers, for addition it's okay, but for subtraction we get minus 2, which is actually not a whole number. If you multiply, see, if we multiply 0 with 3, 3 with 7, any number which are whole numbers, so a into b, will get a whole number. Otherwise, if you divide 5 divided by 8, which is 5 divided by 8, is not a whole number, that is, you can say that whole numbers, they are not closed under division. So the closure property is different for different operations. When we talk about the properties on integers, when we add two integers, that is, if it is a and b, if we add two integers, you'll always get a number which is in turn will be an integer. When we subtract two numbers, again we'll get a number which is actually again an integer. So now the integer is closed under addition also and subtraction also. When we multiply, again we get a number which is an integer. See, 5 into 8 is 40, and if you multiply some negative numbers together, you always get a number which is positive and it is an integer. So a and a into b, or a and b, they are also an integer. But when we try to divide, like 5 divided by 8, where 5 and 8 are integers, you don't get a number which is an integer, because here you can see the example here. So we can see that the previous three, means multiplication, addition and subtraction, in integer terms, they are closed, but for division it is not closed. When we talk about rational numbers, as we indicated, rational numbers are the numbers which can be written in the p by q forms. When p and q are integers, q should not be equal to 0, because anything divided by 0 is not defined. You cannot divide anything by 0. You have to have some number here. These all are all rational numbers. So these are all numbers. Any numbers can be written as p by q form. How? Minus 2. I say it's a rational number. How? I can divide it by 1. So you know how to add two rational numbers now. If you want to add two numbers, I'll just give you a very good way. See, first of all, we have to find out the LCM of these two denominators. So I'll give you a very good idea. You just multiply 4 and 11, 4 into 11. Then you multiply 7 with 6. Then you multiply the denominator, 7 into 11. So this is the solution. For all this you can do just retaining the sign. So when you add, when you subtract, what you get? When you add two rational numbers, you get a rational number. When you subtract two numbers, you get a rational number. That is, rational numbers, they are closed under addition and subtraction as well. Because ultimately, subtraction and addition are nothing but, see, a plus b. And when you subtract, what are you doing? You are adding the negative of that number. So when you take the difference also, you will get the number which is a rational number. So a minus b also will be a rational number if a and b are rational number. How about the product? When we multiply it to p by q form, you will get always a rational number. So if a and b, they are rational numbers, you multiply a into b, you get a rational number. And when you divide, see, this is one number, this is two number, and these are both the p by q form. So when you divide this, see, just devoid of 0. That means if you ignore 0, the rational numbers, they are not closed under division. So if you exclude 0, then the rational number will be closed under division. Because if you see this example, we are getting some minus 25 by 6. So you're getting, in this case also, you're getting some number which is a rational number. And this rational number is, because as I said, that you cannot divide a by 0. So you just have to exclude 0 to make this, or to indicate this as the operation which gives you a rational number which is closed under division. Commutativity. Now commutativity means when we commute, that means we are going from here and there. So exactly that is happening in whole number. When you commute, if you add 0 with 7 or 7 with 0, addition is commutative, you'll get the same answer. Subtraction, multiplication, division, right? If you subtract, you'll not get the same number. Say I multiply 2, say subtract 2 with 7, 7 with 2, you get different result. Multiplication is commutative, division will not be. You can try it out, because division will give you certain numbers which may not fall into the category of whole numbers. Integers also, when you add, or you can say commute, if you say you are adding 2 with 3 or 3 with 2, you will get the same integer, means the number which is an integer falls under the category of integer. When you subtract, again you will get some number which may not be, because subtraction is not commutative here. Because what happens here is, I'm not talking about the closure property, I'm talking about the commutative property. That is, if 5 minus 3 is not equal to 3 minus 5. These two are different numbers, so subtraction is not commutative. And multiplication is also commutative, because if you multiply 2 with 3 and 3 with 2, you are going to get the similar result. Division is also not commutative. You can try it. Rational numbers. When we come to rational numbers, when we add two rational numbers, that is P by Q form, you see that the result will always be a rational number. Two rational numbers, they can be added in any order. So if you add P by Q with C by D, or rather you can add C by D with P by Q, you are going to get the same result. So A plus B is equal to B plus A and B both are rational numbers. When you subtract the rational numbers, since the results are going to be different, that is why we say that subtraction is not commutative for rational numbers. When we multiply, there will be no problem if A cross B and B cross A. If you commute A and B, multiplication is going to give you the same rational number, so it is commutative. When we divide two numbers, see, this divided by this is not equal to this one divided by this, as you see here. So the expression on both sides, they are unequal. So that is why division is not commutative for rational numbers. Associativity. Associativity means if you add, that is add two whole numbers, it will be associative, means you'll get the value properly. If you associate also, I'll give you an example. And then subtraction is not associative here, right? Because we have four operations on whole number: addition, subtraction, multiplication, division. If you multiply, see, this is a sort of a way to explain, means 7 into 2 into 5. What I'm saying is, do 7 into 2 first, like this, and then multiply by 5. The result will be same on both the sides. So multiplication is associative. When we divide, you will not get this, means if I divide 2 divided by 3 divided by 5, this is division, okay? So if I divide 2 by 3, then the result will be by 5. It may not give the same result as if I divide 3 divide by 5 and then divide it by 2. Integers, for these four operations, addition, this is associative. If you add these two together, and add with the third one, it is not going to give you, a different result. So the result will be same. So A plus B plus C is equal to A plus B plus C. If you add these two first, it doesn't matter. In the subtraction, it does matter because the sign will change. That is, subtraction is not associative under integers. The multiplication associative, you multiply this with this first, this with this first, any way you can do. Multiplication is associative. But when you want to divide, see, minus 10 divided by 2, first you divide these two, then divide by minus 5, or you do other way around, you divide these two, then divide the result by minus 10, the division will be different, the result will be different. So division is not associative. Rational numbers. Rational numbers, when it comes to addition, see, when we add this, or when we add in this way, means I'm adding these two first, or rather I'm adding these two, or I can take these two together also. So if we see here the result closely, these two sums are equal, or rather any other way you can combine these, the results will be same. So addition is associative for rational numbers. So A plus B plus C means B plus C you are adding first and A plus C you are adding here. So these remain same. When it comes to subtraction, you will clearly see in these two results, the results will be different. So subtraction is not associative with respect to rational numbers. When we come to multiplication, there will be no problem if you multiply these two together first, or these two together first, or rather A into C into B. It's not going to give you a different result. So the multiplication is associative with multiplication. Division, yes, here the things will be different. If I take these two and divide it by half, or if I take these two and then the result will be 2 by 5, the results are going to be different. So we can say that the division is not associative for rational numbers. Let us take few examples. This is what we can do, how to add these all, as I just suggested earlier. You can take the LCM of this, 7, 11, 21, 22. which comes out to be 462, and then you can just add the numerators because now you have made the denominator as the LCM, and the result will be something like this. You just have to perform these operations, simple operation. We can also solve in some different way. You can combine these two, use this one and this one, and this one and this one. Why? Because 7 is the multiple, or you can say 21 is the multiple of 7, 7 is 21, and 22 is the multiple of 11. That is why we have combined it, so that the formation or the computation of LCM becomes easy for us. 721, we know 21 will be the LCM, here 22 will be the LCM. So easily we can add them, finally you get the same result. So in this way we can give one more example. So if you want to combine these two, or multiply these two, we can multiply these two, and the result is going to be half. Or we can take in another way, means we can use the commutativity and associativity. Means I'm taking now this with this one and this with this one. Multiply them. Why we are taking this? Because 4 4s are 16, 5 3s are 15, 3 3s are 9, 7 2s are 14, and you're going to get the result which you wanted, and the computation will be quite easy. The role of 0. The role of 0 is, for any number, if you add 0 to that number, you'll always get this number again. May it be any integer, may it be any natural number, whole number, or your rational number. So if you add 0 to this rational number, you are going to get the same number back. So this 0 is actually, it comes under the category of whole number. It comes in the integers also. This a plus 0, a can be a whole number, b plus 0, b can be an integer, c plus 0, c can again be a rational number. So if you add them, any of the number with 0, you will get the same number back. That is why 0 is called the identity for the addition. See, this we are adding them. So the 0 is called the identity for the addition of rational number. Okay. The other name of 0 is the additive identity, you can say, for integers and whole numbers as well. What is the role of 1 now? Role of 1 is, you take any number. This number can be a whole number, it can be a rational number, it can be any number, If you multiply that number by 1, what you're going to get? You will get the similar number again, same number. So here what you find when you multiply any number with 1, and especially we are talking about rational number, so you get the same number back. So this 1 is the multiplicative identity of the rational number. This 1 is the multiplicative identity for integers, for whole numbers, for any number. Negative of a number. Negative of a number, if I write 1, that means I'm writing 1, that is, the plus sign is by itself known, right? By default, we don't write plus again and again. This is plus 1, means plus is there. But this number, when we assign a sign, it becomes the negative of 1. So this minus 1 is the negative of 1, and when we add these two, we get a 0. Similarly, 2 added with minus 2, we get a 0. So 2 is nothing but the additive inverse or negative of minus 2, and vice versa. Minus 2 is the additive inverse of 2, or you can say negative of 2, right? So for any general discussion, a and minus a, this a is a number, minus a is the negative or additive inverse. Similarly, if we take specifically the rational number, this rational number, if we assign a sign, that is 2 by 3 is there, I just put a sign. Minus 2 by 3 is the negative or additive inverse. If I say minus 6 by 7, then I apply negative, that is minus of minus 6 by 7, that will be 6 by 7, will be the negative or additive inverse of the minus 6 by 7. This is how all the examples, right? So what we find here is, when we add these two, this is the negative of the number and the original itself, we always get a 0. So a rational number of the form a by b, if it is added with minus a by b, then you get a 0. So this minus a by b in this case is nothing but the additive inverse of a by b. And similarly, a by b is the additive inverse of minus a by b, right? Reciprocal. What is the reciprocal? Reciprocal, you can just say it's a numerator converted to denominator and denominator converted to numerator. They are changing the places, or above goes down, though the down one goes upwards. So any rational number which of this form, say 8 by 21, if you multiply this 8 by 21 with 21 by 8, what do you get? 8 will get cancelled, 21 gets cancelled, and you get 1, right? So this minus 5 by 7 again multiplied by 7 by minus 5, you get 1. So here 21 by 8 is the reciprocal of 8 by 21. In this case, this one is the reciprocal of minus 5 by 7. These are the reciprocal. So this reciprocal, or the other name is multiplicative inverse. The value has a reciprocal or multiplicative inverse. When they both are multiplied, you always get a 1. Please remember, 0 has no reciprocal. You cannot have 0 as 1 by 0. There is nothing called 1 by 0 because this is undefined. You cannot divide anything. You just think over it. You cannot divide anything by 0. Can you? Distributivity of multiplication over addition for rational numbers. Just consider these 3 rational numbers. These are 3 rational numbers, and when you add these 2 and multiply the result by this, what will be the result? Let us solve this. See, you can just take the LCM and solve it. You'll get some 1 by 8, right? Now I'll do another activity. What I'll do here is, I'll multiply minus 3 by 4 with 2 by 3, take them. Then I'll multiply minus 3 by 4 with minus 5 by 6, take them, and then add. The way I was about to do is like this. I multiply these two, and then add. And if you see, the result becomes same. So if you take this multiplication and this is the addition inside, you can perform the distributivity of multiplication or addition, and also the subtraction like this. Multiply this by this, then add the result with this by this, multiplication of this by this. So a into b plus c is nothing but ab plus ac. A into b minus c is nothing but ab minus ac. You have to write the additive inverse of these. So what are the additive inverse? Additive inverse is simply minus 7 by 19. When you want to add this with some x, you ought to get a 0. For that, you just have to take the negative of this. Minus 77 by 19, minus of minus this is plus, so plus 7 by 19 will give you 0. Again 21 by 112, the negative of this is minus 21 by 112, and these two being added, it will give you 0. You have to verify that minus of minus x is same as x for this. 13 by 17, take a negative of this, and minus of minus goes plus, so it will give you the same number. So the other way is, we have 13 by 17, we know, but the additive inverse of 13 by 17 is minus 13 by 17. So when we add these two, we get a 0. And the same equality, this plus the negative of this is going to give you 0. That is why the additive inverse of minus 13 by 7 is 13 by 17 actually, which is 17. So this minus of minus 13 by 17 is going to give you 13 by 17. Right? Minus of minus x is going to give you x. So the second one we take, the additive inverse of x, which is minus 21 by 31. So the minus of x is, you just minus of minus is plus. The minus of minus is plus, that is minus of minus 21 by 31. That will give you 21 by 31. When you add these two, you get a 0. You get a 0. And the same equality means adding 1 with the negative of this will give you 0. It shows that 21 by 31 is indeed, the additive inverse of 21 by 13 is indeed minus 21 by 31, which is minus of minus x is x. Now here what we are going to do, we will use some properties like commutativity and distributivity like this. So here we have certain numbers. What we are going to do here is, this one and this one, these two are similar. So we'll take these two together like these, and we'll take the minus 3 by 7 common. When we take minus 3 by 7, only 2 by 5 will remain here. If we take minus 3 by 7, 3 by 5 will remain here, and this is minus 1 by 14. When you add these two, you get 1, and when you solve it, you get minus 1 by 2. So this is a way how you can employ the commutativity and distributivity together. How to represent the rational number on the number line, because it's quite easy. If you want to represent some natural number, it would be some 1 to 8 in a number line. See, 1, 2, 3 like this. The whole numbers are like this. You start with 0 and similarly go up to say 8 or infinite it goes. And to represent it on a piece of paper, you can represent it like this. When you go to integers, because integers consist of negative and positive, so you have positive here, negative here. This line actually extends indefinitely, right? This again indefinitely exceeding or moving, but in this case they go only to the right side, no left side here, but for the integers it goes to right side also and left side also. So the rational number, they are of the p by q form. So if you have a number line say 0 and 1, so what is this? This is nothing but 0 plus 1 by 2, that is half. What is this? 0 plus half by half. So 0 plus half by half or half, they are again the rational number. So if you want to label 1 by 3, how to do? Say I give 0 to 1, right? Just an example. Now I divide these into 3 parts. So this is what? This is 1 by 3. This is from here to here, it is 1 by 3. And this is 2 by 3, and this is say 3 by 3, and this is 3 by 3 and nothing but 1. So this division or the partition in equally spaced point will get you 1 by 3 or also 2 by 3. Okay, this is how you represent the rational number. And in order, you can also represent the 4 by 6, 5 by 6, 6 by 3. How? 4 by 3 is, or 5 by 3, these are above. These are above 1 point, say 1 point something, 1 point something. As this 7 by 3 is again 2 point something, right? So this way to represent, we need to partition it more. And see, any rational number can be represented easily on the number line in the way I just told you. So rational number, the number which is below the bar, the denominator will tell you how many number of parts you have to make or how much it has to be divided. The number which is above the bar will tell you how many of these parts are to be considered. So if you have a rational number say 4 by 9, it means you need to have 9 equal parts on the say right of 0. Okay, and say minus 7 by 4, minus because it is minus, so takes, or it will tell you that you ought to have 7 markings of distance 1 by 4. This is 4 markings of 1 by 9. This is 7 markings of 1 by 4 size. This is a distance of 1 by 4. So you need to have 7 markings. But it has to be on the left side because it is negative. The 7th marking will be minus 7 by 4. Let me show you here. This 4 by 9 you want to represent. So you have to have 9 partitions. From 0 to 1 you need 9 partitions. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 partitions. This will be, you just have to go to the fourth one. 1, 2, 3, 4. This is 4 by 9. And when you want to say this minus 7 by 4, for that you have to start with 0. You have to go up to minus 1 because this number is higher than here. It was the numerator was lower. Means the magnitude of numerator was lower than the denominator. In this minus 7, or you can say minus 7 by 4 because we have already gone to the left, so we take only 7 by 4. Now in the 7 by 4, numerator is greater than denominator. In this case, what we are going to do here is, because numerator is greater than. So we have to take left, and then because it is greater than the denominator, we have to partition it more. So from 0 to 2, we'll partition it 8 times. These are 8 partitions, and at that this has to be 4, this has to be 4. We take this 7 by 4 partition. Okay. Now rational numbers between two rational numbers. So how many numbers are between these two natural numbers 1 to 5? You can easily count 2, 3, 4. How many between 7 and 9? It's 8. 10 and 11? There are none. Because natural number 10, after 10, 11 will only come. So we have to list the integer that will lie between, say, minus 5 and 4. We can easily make a number line, and in this you can easily show that we have from 0 to 1, 2, 3, and then from here it will be minus 1, minus 2, minus 3, minus 1. Okay? Now the question arises, how many integers are there minus 1 and 1? Is it 0? How many numbers or how many integers are between minus 9 and minus 10 integers? Because minus 9 after minus 9, or you can say minus 9 and minus 10 do not have any integers between them, right? So you will find a definite number of this natural number between two natural numbers. There will be no problem. But how many rational numbers are there between 3 by 10 and 7 by 10? How to find it? Simply see, this is 3 by 10, so you can take 4 by 10, 5 by 10 and 6 by 10. All these 4 by 10, 5 by 10, 6 by 10, these are the numbers. But you can also write 3 by 10 as what? 3 by 100 or 30 by 100. How? 3 by 10 is nothing but multiply numerator and denominator by 10, so it will be 30 by 100. And 7 by 10 can be easily written as 70 by 100, so you get more number, 7 by 10, right? So this is 7 by 10 and 70 by 100. Now 30 by 100 and 70 by 100, you have 31 by 100, 32 by 100. So there are so many numbers in between. So the number of these, actually, if you count, the numbers are total 39. Now 3 by 10 can be now expressed as multiply numerator and denominator by 100. Similarly, multiply numerator and denominator by 100 in this case. So we have 3000 and 7000. So all the numbers starting from 3001 till 699 will lie between these. So there are various numbers, and in fact there are numerous numbers. So we can go on and on inserting the more and more rational numbers between these two. So unlike these natural numbers and integers, the numbers of rational numbers, or you can say the rational numbers, have various rational numbers in between, but they are not definite. I'll give you an example. See, if I can give you an example that how many numbers are there between, or a rational number between minus 1 and 10 and 3 by 10. So it's easily 0 by, say, minus 1 by 10 is there, so 0 by 10, 1 by 10 and 2 by 10. These are the rational numbers between given numbers. But minus 1 by 10 can be easily written as, if you multiply the numerator and denominator by 10 to the power 4, that is, you can say 10,000, and 3 by 10 again by 10 to the power 4 and 10 to the power 4. You get infinite number right from minus 999 to 2999 divided by this 10 to the power 5. So in fact, there are countless rational numbers between any two given rational numbers. They are countless. So this is an example. We have to write three rational numbers between minus 2 and 0. See, so we know that minus 2 and 0, these are integers. And in order to find out the rational number, because we just need three rational numbers. So minus 2 can be written, multiply this numerator and denominator by 10, so you get minus 20 by 10. And this 0 can be written, multiply numerator and denominator by 10, so 0 by 10. Minus 20 by 10 to 0 by 10, so now you have minus 19, minus 18 till minus 1. So these are all the numbers, or you can say the rational number between minus 2 and 0. You can take any three of these. You have to find any 10 rational number between minus 5 by 6 and 5 by 8. So now the question is that the denominators are not same. For that you have to make the denominator common. For that, what we will do, you can take the LCM and you can multiply that with numerator and denominator. You can just easily change 6 is a 24, 8 is a 24. So what we'll do here is we multiply this by 4, numerator denominator by 4, we multiply numerator and denominator by 3. So you get 5 4s are 20, denominator becomes 6 4s are 24, again 8 is a 24. So we have minus 20 by 24 and 15 by 24. Now, because the denominator are same, so you just have to find numbers between minus 20 to 15. So how many numbers are there? There are numerous numbers, and you can take any 10 of these. There is another method also. See, we have to find out a rational number between 1 and 2. How to find? 1 plus 2 by 2 means 1 and 2. You just add them and divide it by 2, so it will be lying somewhere between this. So this number lies between these two. So 1.5, that is 1 by 2 or 3 by 2, you can say. This is the mean. So you can find out this mean. So between any two given numbers, we need not necessarily get an integer, but they will always lie a rational number, as I just told you. And we can use this idea of mean to find rational numbers between any two given rational numbers. See, we have to find a rational number between 1 by 4 and 1 by 2. We just add them and divide by 2. So 1 by 4 plus 1 by 2 divided by 2, you get 3 by 8. You want more? If you want more, you take 1 by 4 and 3 by 8, plus them and divide by 2. You want more? You add 3 by 8 by 1 by 2 and divide by 2. All these will lie in between. See, this is 0. This is say 1 by 4. This is 1 by 2. So when you add these two divided by 2, it comes here. When we add these two divided by 2, it comes here. When we add these two divided by 2, or mean, this comes here. So the midpoint, which is actually in between, this 3 by 8 is going to lie between 1 by 2 and 1 by 4. Actually, this is the mean. So a plus b by 2 will always be between a and b. We have to find three rational numbers between 1 by 4 and 1 by 2. Again, 1 by 4 and 1 by 2, it is quite easy. Just add them and divide by 2, you get 3 by 8. Now you can take these two, 1 by 4 plus 3 by 8 by 2. You get one more number. You get 1 by 2 plus 3 by 8 by 2. You get this number. Again, these two can be added, divided by 2. Or you see, you can take these two numbers and divide by 2. So you get numerous numbers. So I hope you got the idea by now. These all can be combined, Anything which is combined in between these two always fall in between. So what we have discussed in this chapter, rational numbers are closed under the operations of addition, subtraction, multiplication. And the operation addition and multiplication, they are commutative first of all, and they are also associative with respect to the rational numbers. The 0 in the rational number is called as the additive identity. The 1 is called the multiplicative identity when it comes to a rational number. The additive inverse of any rational number of p by q form or a by b form is nothing but minus a by b, and this is vice versa also. The reciprocal or multiplicative inverse of a rational number a by b is, if it is c by d, it has to be a by b into c by d has to be equal to 1. The distributivity of rational number for all these rational numbers a, b, c. See, if you multiply a with b plus c, you get ab plus ac. Again, a into b minus c is nothing but ab minus ac. Then we have rational numbers. This can all be represented in the number line. And between any two given rational numbers, there are countless, infinite rational numbers. And the idea of mean, it will help us to find more and more numbers between two rational numbers. So this is all about this chapter. Thank you so much and take care of yourself.